Here's something wild happening at SpaceX's McGregor test facility right now. Perfectly functional Raptor 2 engines, dozens of them, some that never even flew a single mission, are being sent to the scrapyard. These aren't failed engines, they work flawlessly. So why would SpaceX scrap millions of dollars worth of working hardware? What makes Raptor 3 so transformative that Raptor 2 became instantly obsolete? And what does this aggressive move reveal about Starship version 3's timeline? Recent footage from McGregor shows something that looks crazy at first. Dozens of Raptor 2 engines sitting there, perfectly functional, many never fired beyond testing, just heading to the scrapyard. We're talking millions per engine being written off, but look deeper. This isn't waste. It's actually the clearest signal yet of how confident SpaceX is in Raptor 3. Musk's been saying for years that the only way to design a truly mass-producible engine is to actually mass-produce it and find the problems. Raptor 2 was never the end goal. It was a learning platform. Every single engine taught the Hawthorne team something about bottlenecks, quality issues, production flow. What's profound here is that SpaceX has learned everything Raptor 2 can teach them. They've hit the point where keeping these engines around would slow them down. Think about that. Raptor 3 isn't just marginally better, it's so fundamentally superior that maintaining compatibility with the old generation becomes a liability. That's not an upgrade. That's a generational leap. You can see this confidence everywhere at Starbase right now. Take the integrated hot staging ring on version 3 boosters. Complete structural redesign that eliminates the separate ring entirely. Since September, they've been hammering B18.3 with 7 cryogenic proof tests to verify tank strength. Now there's this specialized adapter that lets them literally squeeze the hot stage trusses, making absolutely sure these connections can handle forces from 33 Raptor 3 engines firing during separation. Meanwhile, Ship 39 is sitting in Mega Bay 2 with scaffolding around it, which immediately got people speculating. Was the heat shield coming off? Did they find something wrong? Was Flight 12 about to slip? But check this out. Ship 39's heat shield is the cleanest, most pristine thermal protection we've ever seen at Starbase. If there were fundamental problems, you wouldn't see this level of polish. What's probably happening is swapping out a few tiles or testing new attachment methods, standard iteration stuff. The timing actually tells you everything. That ship static fire stand at Massey's? Still under construction. Even if they wanted to roll Ship 39 out tomorrow, the infrastructure isn't ready. They've got breathing room to fine-tune things without touching the Flight 12 schedule. That's not delay. That's smart planning. Now, those explosions that took out Ship 36 and Booster 18 turned out to be valuable lessons. SpaceX traced the root cause to COPV ground handling procedures. Those composite pressure vessels that store helium for pressurizing the tanks were failing during ground ops, not flight. That distinction matters because it meant the fix was process-based, not some fundamental design problem. The response was fast and surgical. They built a dedicated COPV tester at Massey's. Every COPV now gets a bright red protective cover during handling. More critically, they're testing every single COPV before installation now. That's acknowledging ground handling as a failure mode they'd underestimated. Booster 19 proves these fixes work. Stacking started November 25th, just 4 days after the Booster 18 failure, and wrapped December 24th. Less than a month while rolling out brand new safety procedures. If these changes were creating problems, you'd see longer integration times. Instead, acceleration. That tells you they actually solved the core issue. But none of this matters without the pad infrastructure keeping pace. Pad 1 is the real bottleneck. Most people aren't watching closely enough. SpaceX's entire 2026 manifest collapses if they can't upgrade that orbital launch mount. Right now, workers are digging through what might be thousands of tons of steel-reinforced concrete from the pile cap under the old deluge plate. Some people predicted this would take months. They underestimated how SpaceX operates. Even during New Year's Eve fireworks, those excavators kept running. 2 weeks later, they'd cleared most of the pile cap. Next comes the new flame trench, which fundamentally changes how Starship launches, because version 3's integrated hot staging creates different acoustic loads, and Raptor 3's higher thrust redistributes forces across the mount. Over at Pad 2, teams installed flex hoses on the ship Quick Disconnect, December 28th, probably one of the last steps before attaching it to Mechazilla. Same day, they ran extensive tank farm tests for hours without issues. This parallel development across both pads shows you their thinking. They're not just iterating vehicles faster, they're evolving the entire ground system simultaneously. Any bottleneck in one area ripples everywhere else. So let's talk about what actually needs to happen this year, because the timeline is brutal. Flight 12 kicks off version 3, probably late January or early February. SpaceX requires 2 successful flights before attempting a catch. Flight 13 validates the design. Flight 14 becomes the earliest catch attempt. If Flight 12 goes in January and they hold monthly cadence, Flight 14 hits around June or July. Orbital refueling is where things get really tight. This tech is absolutely non-negotiable for Artemis 3. NASA can't send astronauts to the lunar surface without it. SpaceX will probably want 2 successful catches before trying propellant transfer. First catch in July, second in September, refueling test on Flight 16 in November at best. Every delay multiplies. We're not even counting environmental reviews, regulatory hoops, or the technical surprises that always come up. This is exactly why SpaceX is scrapping those Raptor 2 engines. They can't afford delays from supporting obsolete hardware. Every day maintaining legacy systems costs them progress toward deadlines that don't move. There's one more piece that changes the game. December 29th, a barge showed up at Kennedy Space Center, test run for transporting boosters and ships to the Cape. Pad 39A will be operational before Florida's production is ready, so they'll build in Texas and ship across the Gulf. This doubles their geographic launch capacity, but more importantly, it builds resilience into the program. Texas hits regulatory delays, Florida keeps launching. Florida pad issue grounds operations, Texas picks it up. They're building redundancy at the system level. That's how you maintain aggressive flight rates when any single failure point could shut everything down. All of this is in service of one target, the Moon. Artemis 2 launches no later than April, but Artemis 3 needs Starship HLS, and right now there's no public hardware beyond concept images. With Jared Isaacman running NASA now, HLS carries huge political weight for SpaceX. Expect at least a full-scale mock-up by mid-year for training and public confidence. Bottom line, if SpaceX pulls off Flight 12, catches, and orbital refueling in 2026, They set themselves up for HLS orbital tests in 2027 and maybe even lunar flight that year. But only if everything goes perfectly. There's zero margin for error. Those scrapped Raptor 2 engines? They represent SpaceX betting on short-term costs for long-term speed. It's aggressive, it's expensive, and right now it's the only strategy fast enough for NASA's timeline. SpaceX is all in on hardware-rich development. 2026 shows us if that bet pays off. So those scrapped engines tell the whole story. SpaceX isn't just confident in Raptor 3. They're so certain keeping the old generation around would slow them down. That's not recklessness. That's clarity. When you're chasing deadlines as tight as Artemis 3, trying to nail ship catches, orbital refueling, and lunar missions all in 1 year, you can't afford to support yesterday's systems. Hardware-rich development at maximum aggression. Short-term costs for long-term velocity. 2026 proves whether it works, because there's zero room for mistakes. What do you think? Will they hit orbital refueling by year's end? Drop your prediction in the comments. If this breakdown helped you understand what's really happening at Starbase, hit that like and subscribe to New Space Review so you catch what comes next. Thanks for watching. You make this content possible. And if you want the full story of how SpaceX went from nearly bankrupt to dominating spaceflight, click that video on your screen. What is SpaceX? From reusable rockets to Mars plans explained. See you there.